Hello. Welcome to the content of Chapter Number 5, Part 2 of the Asbestos Removal Program. Preparation of the Work Area. This presentation has been created and designed by Active Environmental Training. Active Environmental Training is proud to grow with you. That is why we try to maintain the highest standards in teaching for our students. At Active Environmental Training, we strive to use the most advanced teaching methods in the industry to provide our students with the best quality training materials using the latest technology. So that's it. Feel at ease. Just relax. And let the informative material flow and be an additional part of your professional knowledge. With this in mind, let's start with our program referring to Chapter 5, Preparation of the Work Area. Remember, you can contact Active Environmental Training at any time if you feel you have questions or concerns related to this or any other professional safety or environmental issue. Call Active Environmental Training at 407-860-0369 or visit us on the internet at www.activet.com. Your comments are always welcome. HEPA filters, primary filters, secondary filters. HEPA filters, primary filters, and secondary filters are key components in air filtration systems used in a variety of environments to improve air quality by capturing fine particles and contaminants. Here is a description of each. HEPA, high-efficiency particulate air filters. HEPA filters are recognized for their high efficiency in retaining small particles. They are designed to capture particles with a size of at least 0.3 microns with a filtration efficiency of 99.97%. These filters are effective at retaining fine particles, including dust, pollen, spores, bacteria, and asbestos fibers. They are essential in environments where very high air quality is required, such as laboratories, clean rooms, and hazardous materials removal areas. Primary filters. Primary filters, also known as pre-filters, are the first filters in an air filtration system. Its main function is to capture larger particles, such as dust, hair, and other coarse particles that could clog or reduce the efficiency of finer filters, such as HEPA. Pre-filters extend the life of more advanced filters by trapping large particles before they reach high-efficiency filters. Secondary filters. Secondary filters are placed after pre-filters and, in some cases, before HEPA filters. Its goal is to capture smaller particles that may have passed through the pre-filters, but are still large enough to be efficiently captured by the secondary filters. These filters help improve air quality by reducing the particle load that reaches the HEPA filters. In summary, in an air filtration system, primary filters are found at first to capture large particles, followed by secondary filters that address smaller particles, and finally, HEPA filters, which are highly efficient at capturing particles extremely small. The combination of these filters in one system provides comprehensive protection against various particles and contaminants present in the air. It is important to perform regular maintenance and replace filters according to the manufacturer's recommendations to ensure optimal performance of the filtration system. The asbestos work area air exhaust system. The air exhaust system in an asbestos work area is essential to maintain a safe environment and control the spread of asbestos fibers. Common features of air exhaust systems in these areas are described here. Contaminated air extraction. The exhaust system is designed to remove air contaminated with asbestos fibers from the work area. This helps prevent inhalation of these fibers by workers and prevents the spread of contaminants to the surrounding environment. Controlled ventilation. Controlled ventilation is essential to direct airflow and ensure that asbestos fibers are captured and removed effectively. There may be one-way ventilation systems that prevent recirculation of contaminated air. Negative pressure. In some cases, a negative pressure system can be implemented in the work area. This means that the pressure inside the contaminated area is lower than the pressure outside, preventing the leakage of asbestos fibers to the outside. High-efficiency filters. Exhaust systems may be equipped with high-efficiency filters, such as HEPA filters, to capture asbestos fibers and other fine particles present in the air before releasing them to the outside. Continuous monitoring. The effectiveness of the exhaust system is verified by continuous monitoring of air quality. This may include measuring the concentration of asbestos fibers and ensuring levels are within safe limits. Regulatory compliance. Exhaust systems in asbestos work areas must comply with local and international standards and regulations related to the safe management of asbestos and air quality. This may include specific requirements on the number of air changes per hour, for example. Ensure controlled air direction. It is important that the exhaust system directs contaminated air to safe areas and prevents asbestos fibers from spreading. This may require careful planning of the design and placement of air vents. Containment systems. In some situations, especially during asbestos removal, physical containment systems, such as barriers or curtains, can be used to ensure that contaminated air is removed in an effective and controlled manner. The design and implementation of an effective exhaust system is essential to ensure worker safety and prevent environmental contamination during asbestos-related activities. These systems must be planned and operated carefully and in accordance with applicable regulations and standards. The air is sucked through the negative air machine, filtered with HEPA filters, and extracted from the work area through flexible hoses to the outside. Here are some key points related to exhaust air from the work area. Negative air machine. This machine, also known as a negative pressure system, is designed to maintain a working environment where the air pressure inside the contaminated area is lower than the outside air pressure. This helps prevent contaminants, such as asbestos fibers, from leaking out of the work area. Filtration with HEPA filters. The air sucked through the negative air machine passes through HEPA filters. These high-efficiency filters are designed to capture extremely small particles, including asbestos fibers. This ensures that the air released to the outside is as clean as possible. Extraction using flexible hoses. After passing through HEPA filters, the filtered air is extracted from the work area through flexible hoses. These hoses allow air to be directed outside in a controlled manner. Controlled outward discharge. Flexible hoses are used to direct the treated air in a controlled manner to the outside. This helps prevent leaked particles, including asbestos fibers, from being released into nearby areas. Continuous monitoring. Throughout the process, continuous monitoring is performed to ensure that the system is functioning properly. This may include checking negative pressure, the effectiveness of HEPA filters, and the quality of the air released to the outside. This environmental control approach, with the combination of negative pressure, HEPA filters, and controlled extraction, is essential to reduce the risk of exposure to hazardous contaminants such as asbestos. In addition, it is important that this system is in compliance with local regulations and standards related to the safe management of asbestos and environmental protection. Air extracted from the work area by negative air machines after passing through HEPA filters is considered 99.97% clean, which is consistent with the typical filtration efficiency of HEPA filters. 99.97% filtration efficiency refers to the ability of HEPA filters to retain particles as small as 0.3 microns with an efficiency of 99.97%. This means that, under normal operating conditions, these filters can capture almost all particles that size or larger, including asbestos fibers, bacteria, mold spores, and other contaminants. It is important to note that filtration efficiency may vary slightly depending on the specific filter design and operating conditions. Additionally, the 99.97% clean claim refers specifically to particle holding capacity, but does not guarantee the complete absence of any contaminants. Air quality in the work area also depends on proper operation and maintenance of the system, as well as continuous monitoring to ensure that the equipment is performing as expected. In summary, systems that use negative air machines with HEPA filters are an effective measure to control and reduce the presence of contaminants in the air, offering a cleaner and safer environment, especially in environments where hazardous materials such as asbestos are handled. Special HEPA filters to filter water. There are HEPA filters designed specifically for water filtration. These HEPA filters for water are constructed differently than HEPA filters used for air filtration. While conventional HEPA filters are designed to trap particles in the air, HEPA filters for water are designed to retain particles in the water. Features of HEPA water filters. Specific materials. HEPA water filters are constructed of water-resistant materials and designed to work properly in aqueous environments. Specific structure. The structure and design of HEPA water filters allow the retention of particles in the water, such as sediment, dirt, and other contaminants. Particle retention. Like HEPA air filters, HEPA water filters are designed to retain small particles. Retention efficiency can vary, but they are expected to capture a wide range of contaminants present in water. Specific applications. These filters are commonly used in home water purification systems, as well as in industrial and commercial applications where effective water filtration is required. It is important to note that the application of HEPA filters for water is not as common as their use in air filtration systems. For water, other types of filtration technologies are more often used, such as filter cartridges, sediment filters, and reverse osmosis systems, which are specifically designed to address the unique challenges of water filtration. When choosing a water filter, it is essential to understand the specific characteristics of the water to be treated and select a filtration system that is appropriate for the contaminants present in the water supply. The portable mechanism used for asbestos water filtration includes following: electric water pump. An electric water pump is a device that uses electrical energy to pump water from one place to another. In this context, it is used to drive the flow of water through the filtration system. 20-micron HEPA water filters. These HEPA water filters are designed to retain particles in the 20-micron size range. This would include larger particles such as sediment and visible contaminants in the water. 5-micron HEPA water filters. 5-micron HEPA water filters are finer than 20-micron HEPA filters and are designed to capture smaller particles. This may include finer and smaller particles that 20-micron filters would not retain. Hose to direct filtered water to drain. The hose is a flexible conduit used to direct filtered water to a drain or any other desired destination after passing through the HEPA filters. This mechanism is set up so that the electric pump drives the water through the 20-micron HEPA water filters and then through the 5-micron filters, retaining particles of different sizes. The filtered water is then directed through a hose to the drain. It is important to note that while HEPA filters are effective at retaining fine particles, other filtration methods, such as reverse osmosis filtration, can also be used to address specific contaminants in water, including those derived from asbestos or other minerals. In addition, regular maintenance and replacement of filters is essential to ensure the continued effectiveness of the filtration system. There are numerous power cutting and abrasive tools today that are designed with built-in systems for immediate dust collection, often by incorporating vacuum cleaners with HEPA filters. These tools are commonly used in environments where fine particles are generated, such as dust generated during cutting or sanding materials, including those that may contain hazardous substances such as asbestos. Some examples of tools equipped with dust extraction systems include circular saws with vacuum cleaners. Circular saws designed with dust collection systems that vacuum the dust generated during cutting. These vacuum cleaners usually incorporate HEPA filters to retain fine particles. Angle grinders with suction system. Angle or radial grinders that include dust collection systems to vacuum up dust generated during sanding or cutting. These tools often have adapters to connect to external vacuum systems. Cement cutters with dust collection. Tools for cutting cement or masonry with integrated dust collection systems to keep the work environment clean. Orbital sanders with vacuum cleaners. Electric orbital sanders designed with dust collection systems to vacuum up fine particles generated during sanding. Multifunction tools with suction. Multifunction tools that can perform various tasks, such as cutting and sanding, with integrated vacuum systems for dust collection. The inclusion of vacuum cleaners with HEPA filters in these tools is an effective measure to control the dispersion of dust in the air and reduce the exposure of workers to fine particles that can be harmful to health. This is particularly important in environments where you work with materials that may contain hazardous substances. It is essential to follow the manufacturer's recommendations for the safe and effective use of these tools, as well as for the maintenance and cleaning of dust collection systems. In addition, local regulations and standards related to the safe management of dust and hazardous substances must be followed. Proper location of negative air machines. Proper placement of negative air machines is a crucial factor in ensuring effective air quality management in a contaminated area, such as one where asbestos or other hazardous materials removal is being performed. Placing negative air machines strategically is essential to achieve adequate containment of contaminants. It is an excellent practice to place them as far as possible from the entrance to the work area, decking. Here are some reasons for it. Pollutant leak prevention. Placing negative air machines away from inlets helps prevent contaminants, such as asbestos fibers, from leaking into uncontrolled areas. The machines are designed to create a negative pressure so that the airflow is directed from uncontaminated areas towards the contaminated work area, minimizing the risk of dispersion. Airflow control. By strategically placing negative air machines, you can better control the airflow within the contaminated area. This helps direct contaminated air toward filtration machines and away from clean areas. Containment optimization. Locating negative air machines so that their influence covers most of the contaminated area contributes to better containment. This translates into greater efficiency in capturing and filtering contaminants. Avoid interference with other equipment. Moving negative air machines away from inlets can also help avoid interference with other activities or equipment in the work area. This ensures efficient operation without obstacles. Facilitate monitoring. The strategic location of the machines facilitates continuous monitoring of air quality in the contaminated area. There may be sensors or measuring instruments in place to evaluate the effectiveness of the system. Importantly, the precise location may depend on workplace-specific factors such as space layout, layout of entrances and exits, and environmental conditions. Decisions regarding the location of negative air machines should be based on a careful evaluation of these factors and comply with local regulations and standards related to the safe management of hazardous materials. Negative pressure. As air is removed from the work area, new air begins to enter continuously through the decking. This concept is part of the design of environmental control and safety systems in areas where the removal or manipulation of hazardous materials such as asbestos is carried out. The process involves creating a negative pressure in the work area to prevent the escape of contaminants and, at the same time, ensuring a controlled supply of fresh air through a decontamination area, decking. Here is a more detailed description. Negative pressure in the work area. Negative air machines create a negative pressure within the work area where hazardous materials removal is taking place. This negative pressure helps direct airflow from uncontaminated areas into the work area, preventing contaminants, such as asbestos fibers, from escaping into the surrounding environment. Decontamination area, decking. The decontamination area is an area between the contaminated work area and the clean environment. Here, workers can decontaminate themselves before leaving the contaminated area. The decking usually has several sections, including a clean room, a shower, and a dirty room. Controlled airflow. The negative pressure in the work area also affects the airflow in the decking. As air is being extracted from the work area, a low-pressure zone is created in the decking. This helps ensure that fresh air enters the work area from the decking, rather than allowing contaminated air to escape. Controlled fresh air in the decking. At the decking, controlled fresh air is supplied to maintain a clean and safe environment for workers who are entering or leaving the contaminated area. This contributes to the protection of workers' health and the prevention of the dispersion of contaminants outside the work area. Controlled decontamination of workers. Workers leaving the contaminated area go through the decontamination process at the decking, which may include using showers and changing clothes. This helps minimize the risk of carrying contaminants with you outside the work area. This comprehensive approach, which includes the creation of negative pressure, the use of negative air machines, and a decontamination area, is essential to ensure safety and effectiveness in the management of hazardous materials such as asbestos. In addition, all practices must comply with applicable local regulations and standards. Some visual effects that negative pressure indicates. Some visual examples of negative pressure, such as the lifting of the poly covering the walls and floors, as well as the movement of the decontamination area, decking, curtains inward, are indicative of the presence of a negative pressure in the work area. These visual phenomena are a consequence of the controlled flow of air from clean areas to the contaminated work area. Here is a more detailed explanation. Polylifting on walls and floors. When negative pressure is created in the work area through the use of negative air machines, the airflow is directed from uncontaminated areas into the work area. This airflow can cause barriers, such as polyethylene covering walls and floors, to lift slightly. This phenomenon is visual evidence of the direction of the controlled airflow towards the contaminated area. Movement of the decking curtains inward. The decontamination area, decking, acts as a barrier between the contaminated area and the clean environment. The negative pressure in the work area contributes to creating a low pressure zone in the decking. As a result, fresh air from the clean environment will be directed toward the work area, causing the decking's curtains or barriers to move inward. This inward movement indicates that the airflow is controlled and directed from the outside towards the contaminated area. These visual effects are important signals that environmental control measures are operating as intended. Negative pressure and controlled airflow are key components of safety strategies in situations where hazardous materials, such as asbestos, are handled. Additionally, these visual effects can be closely monitored as part of ongoing air quality and workplace safety management. The negative pressure of the asbestos removal area must be constantly monitored and recorded with special monitoring equipment. This tool is known as a manometer. The negative pressure in the asbestos removal area must be constantly monitored, and a commonly used tool for this purpose is the manometer. The manometer is a measuring instrument used to determine the pressure in a specific system or area. In the context of asbestos removal, the manometer is used to measure the negative pressure in the contaminated work area. Here are more details about its function and usage. Manometer function. The pressure gauge is installed in the contaminated work area and measures the pressure difference between the interior of that area and the surrounding environment. The resulting reading indicates whether the necessary negative pressure to prevent contaminant leakage has been achieved and is being maintained. Constant monitoring. Negative pressure must be constantly monitored during asbestos removal operations. This ensures that a safe and controlled environment is maintained at all times. Any unwanted change in negative pressure is quickly detected by the manometer. Adjustment and maintenance. Removal personnel can adjust and maintain negative pressure as necessary based on manometer readings. Ensuring that the environmental control system is working properly is essential for worker safety and preventing the release of contaminants. Data logging. In addition to providing real-time readings, some manometers are designed to record data over time. This allows the creation of a history of negative pressure conditions during operation, which is useful for long-term monitoring and to demonstrate compliance with standards and regulations. The use of the manometer is standard practice in the safe management of the removal of asbestos and other hazardous materials. It is essential to follow the manufacturer's recommendations for the installation, calibration, and operation of the manometer. In addition, any unusual readings or loss of negative pressure must be addressed immediately to maintain a safe work environment and comply with applicable regulations. A manometer is a measuring instrument designed to measure and display the pressure of a specific fluid, gas, or environment. In the context of asbestos removal and creating negative pressure in contaminated work areas, manometers are used to monitor and control the differential pressure between the contaminated work area and the surrounding environment. Here is a detailed description of a manometer. Types of manometers. There are several types of manometer, but in the context of asbestos removal, differential manometers are commonly used. These manometers measure the pressure difference between 2 points, in this case, the pressure inside the contaminated area and the pressure outside it. Main components. A manometer typically consists of a dial or display screen, a graduated scale that shows pressure readings, and an indicator needle that points to the current pressure. Some manometers also have settings and controls to calibrate the instrument. Negative pressure. In the context of asbestos removal, the manometer is used to measure and display negative pressure. Negative pressure is created by maintaining an internal pressure lower than the external pressure, thus preventing the leakage of contaminants. Installation. The manometer is installed in the contaminated work area and connected to specific points to measure the differential pressure. Tubes or hoses are installed that allow the manometer to compare the pressure inside and outside the area. Real-time readings. The manometer provides real-time readings of differential pressure. Workers can monitor these readings to ensure that the negative pressure required to control contamination is being maintained. Data logging, optional. Some manometers have the ability to record data over time. This allows a history of pressure conditions in the contaminated area to be created, which is useful for long-term monitoring and regulatory compliance. Calibration and maintenance. It is essential to calibrate the manometer regularly to ensure accurate measurements. Additionally, maintenance procedures must be performed according to the manufacturer's recommendations. The manometer is a critical tool in ensuring a safe working environment during asbestos removal and other operations requiring environmental pressure control. Its use allows effective management of negative pressure and contributes to the protection of workers' health and compliance with safety regulations. The minimum negative pressure within the asbestos removal work area should be -0.02 inches of water, according to OSHA standards. The negative pressure required in the work area during asbestos removal is essential to prevent the leakage of contaminants into the surrounding environment. The figure mentioned of 0.02 inches of water is a negative pressure commonly used as a reference in environmental control and occupational safety practices related to asbestos removal. It is important to note that regulations and standards may vary by location and jurisdiction, and specific standards may have been updated after my last known date in January 2022. It is strongly recommended to consult local regulations and relevant occupational safety standards for the most up-to-date and specific information. It is always crucial to comply with applicable regulations and work with trained and certified professionals when it comes to asbestos removal operations to ensure the safety of workers and the general public. How does an air differential manometer in an asbestos removal work? An air differential manometer in an asbestos removal work area is used to measure the differential pressure between the interior of the work area and the surrounding environment. This instrument is essential to ensure that the necessary negative pressure is maintained to prevent the leakage of contaminants, such as asbestos fibers, out of the work area. Here is a description of how an air differential manometer works in this context. Main components. Connecting tubes or hoses. Tubes or hoses are installed that connect the manometer to specific points inside and outside the work area. These tubes allow the manometer to compare pressures between the work area and the outside environment. Differential manometer. The manometer itself consists of a display screen or dial with a graduated scale. It also has an indicator needle that indicates the current differential pressure reading. Operation process. The manometer is installed in a strategic location within the contaminated work area. The tubes or hoses are connected to specific points that represent the pressure inside and outside the area. The pressure gauge compares the pressure inside the working area, negative pressure, with the pressure in the outside environment. The difference between these two pressures is shown on the manometer scale. Responsible personnel constantly monitor manometer readings in real time. This ensures that the necessary negative pressure is being maintained to prevent the dispersion of contaminants. If necessary, staff can make adjustments to keep the negative pressure within the required range. It is important to calibrate the manometer regularly to ensure accurate measurements. Some manometers have the ability to record data over time. This provides a history of pressure conditions in the work area, which can be useful for long-term monitoring and regulatory compliance documentation. A constant reading within the specified range indicates that negative pressure is being effectively maintained, contributing to personnel safety and prevention of contaminant release. It is essential to follow the manufacturer's recommendations for the installation, calibration, and maintenance of the manometer. Additionally, local regulations and applicable occupational safety practices must be followed to ensure safe operations during asbestos removal. Additional asbestos work area preparation may be necessary when applicable. Additional preparation of the asbestos work area is crucial to ensure a safe and controlled environment during asbestos handling or removal operations. Here are some additional considerations that may be necessary when applying preparedness measures in the asbestos work area. Prior to any work in the asbestos area, it is essential to carry out a thorough assessment to identify the location and extent of asbestos-containing materials. This includes performing inspections and testing to determine the presence of asbestos in materials such as insulation, ceilings, walls, and floors. Conduct a detailed risk assessment to understand and address the potential dangers associated with the presence of asbestos. This includes consideration of factors such as the amount of asbestos, location, condition of materials, and potential worker exposure. Develop a detailed work plan that includes the sequence of operations, dust control methods, access routes, decontamination areas, and other essential aspects. This plan must follow local regulations and industry best practices. Ensure workers are properly trained and equipped with necessary personal protective equipment, PPE, such as disposable coveralls, gloves, respirators, and safety glasses. Establish appropriate decontamination areas, including clean rooms, showers, and dirty rooms. These spaces are essential to ensure that workers can decontaminate themselves before leaving the contaminated area. Implement effective strategies for dust control, such as the use of containment systems, wetting of the asbestos material, and the application of binding agents to minimize the dispersion of asbestos fibers. Establish a plan for the safe management of asbestos waste, including its proper disposal and transportation in accordance with local regulations. Implement a continuous environmental monitoring system to evaluate air quality in and around the work area. This may include the installation of asbestos particulate monitors and differential pressure gauges. Conduct post-removal assessments to verify the effectiveness of the measures taken and ensure the area is free of contaminants before allowing access to unauthorized personnel. The practice of covering all mechanical and electrical systems above the false ceiling level with plastic is an additional protective measure that may be necessary in certain situations during asbestos removal or handling operations. This measure aims to prevent contamination of these systems and components with asbestos fibers released during work. Here are some considerations. Covering mechanical and electrical systems with plastic helps prevent asbestos fibers released during removal operations from coming into contact with these components. Contamination of critical systems could have negative consequences for health and safety, as well as long-term equipment performance. In some jurisdictions, coverage of mechanical and electrical systems may be a regulatory requirement to ensure compliance with specific safety and environmental regulations. It is important to note that the need to plastic cover mechanical and electrical systems may vary depending on the nature of the work, specific site conditions, and local regulations. Before performing any asbestos-related work, the specific occupational safety and environmental regulations and guidelines applicable to the jurisdiction in which the work is performed must be followed. Additionally, it is recommended that you consult with certified asbestos management professionals for specific guidance for the situation at hand. During the removal of asbestos-containing material, the material must be wet before, during, and after removal. The process of wetting material with asbestos before, during, and after removal is a common practice and a key environmental control measure. Wetting asbestos material helps minimize the release of asbestos fibers into the air, thereby reducing the risk of occupational and environmental exposure. Here are the benefits of wetting the material with asbestos at each stage of the process. Before removal. Wetting the material with asbestos before beginning removal helps suppress dust and adhere asbestos fibers to surfaces. This makes the fibers less likely to be released into the air during initial handling and preparation of the work area. During removal. Continuing to wet the material during removal keeps the asbestos fibers moist and prevents them from dispersing into the air. Additionally, wetting helps reduce the amount of dust generated during the cutting, dismantling, or material handling process. After removal. Wetting the area after removal helps suppress any residual dust and ensure that any asbestos fibers that may be left on the surfaces stay moist. This is especially important before final cleaning and decontamination of the area. Wetting is typically done with water, and in some cases, special solutions containing binding agents may be used to improve the effectiveness of dust suppression. It is essential to follow specific safety guidelines and procedures established by local and national regulations, as well as industry best practices, during all stages of handling asbestos materials. Additionally, it is important that people involved in asbestos removal use appropriate personal protective equipment, PPE, including respiratory masks, to reduce exposure to asbestos fibers, even when water is being used to moisten the material. Once the asbestos-containing material has been removed, it must be collected in 6 mm thick plastic bags. After removing asbestos materials, it is common to collect and dispose of the waste in thick plastic bags. The use of plastic bags at least 6 mm thick is standard practice to ensure the safe containment of asbestos waste and comply with environmental and safety regulations. Here are some important considerations related to the collection and disposal of asbestos waste. Resistant plastic bags. Plastic bags must be strong enough to safely contain asbestos materials without risk of breaking or releasing fibers. Bags at least 6 mm or 0.006 inches thick provide an effective barrier. Double bagging. In some cases, double bagging of asbestos waste may be required to provide an additional layer of containment and reduce the risk of exposure. Proper labeling. Bags of asbestos waste must be clearly and accurately labeled to indicate the presence of hazardous materials. This helps waste management workers and disposal teams identify and properly handle asbestos waste. Hermetic sealing. The bags must be sealed tightly after containing the asbestos waste. This is done to prevent the leakage of asbestos fibers during transportation and disposal. Safe transport. During transportation of asbestos waste, applicable safety procedures and regulations must be followed. This includes the use of appropriate vehicles and adherence to hazardous materials transportation regulations. Regulatory elimination. Final disposal of asbestos waste must be carried out in accordance with local and national regulations. This could involve delivering the waste to waste disposal facilities licensed and certified to handle asbestos-containing materials. It is crucial to follow all specific asbestos management regulations and procedures established by local and national regulatory authorities. Improper handling of asbestos waste can pose health and environmental risks. Therefore, it is highly recommended to have trained and certified professionals to carry out asbestos removal and disposal safely and legally. Double bagging is necessary to be able to remove the material from the work area. Double bagging is a recommended practice in some cases to provide an additional layer of containment and safety when handling and transporting asbestos waste. The decision to use double bagging may depend on local regulations and specific waste management policies in your area. Here are some considerations about double bagging in the context of asbestos removal. Additional protection. Double bagging provides an additional layer of protection, reducing the risk of asbestos fiber release during handling and transportation. This approach can be especially useful when working with materials that could be abrasive and potentially puncture the outer bag. Regulatory compliance. Some local regulations or waste management policies may require double bagging as part of the safety measures for asbestos waste disposal. Check your jurisdiction's specific regulations to ensure you comply with local requirements. Avoid additional contamination. Double bagging can help prevent additional contamination during the transportation and disposal process. If an outer bag is damaged, the second layer of bag provides an additional barrier. Practical considerations. In some cases, double bagging may be a standard practice adopted by asbestos removal companies or required by waste disposal facilities. Check best practices in your specific industry or area. Please remember that practices and regulations may vary by location and jurisdiction. It is always essential to follow local and national regulations and consult with professionals trained in asbestos management to ensure safe and legal handling of waste. In addition to double bagging, ensure bags are properly sealed and labeled in accordance with applicable regulations before transporting them out of the work area. Having removed the bagged material, it is time to begin the final cleaning process. Final cleanup is a crucial phase after removing bagged asbestos-containing material. This process is essential to ensure that any asbestos residue or particles that may have been left in the work area are completely removed and that the site is safe for access without health risks. Here are some key steps in the final cleanup process after asbestos removal. Visual inspection. Perform a thorough visual inspection of the area to identify any asbestos residue or material that may be left behind. This inspection must be carried out before starting cleaning. Wet cleaning. Use wet cleaning methods to collect any dust or asbestos residue that may be present on surfaces. Wet cleaning helps remove asbestos fibers and prevent their dispersal into the air. Vacuum cleaners with HEPA filters. Use vacuum cleaners with high-efficiency filters, HEPA filters, to clean any dust or fine asbestos particles. These vacuums are designed to capture very small particles and reduce fiber dispersion. Surface decontamination. Decontaminate all surfaces with specific solutions for this purpose. Be sure to follow the manufacturer's recommendations and applicable regulations. This may include the use of decontamination agents and water. Cleaning residue removal. Collect and properly dispose of all cleaning materials, such as rags, sponges, and any other items used during the cleaning process. These wastes must also be managed as asbestos-contaminated materials. Environmental monitoring. Conducts air quality testing and environmental monitoring to verify that asbestos fiber levels in the area are within acceptable limits. This is especially important before allowing access to people not involved in the removal. Documentation. Document all final cleaning activities, including methods used, cleaning products, monitoring results, and any other relevant details. This is essential for registration and regulatory compliance. Post-inspection. After final cleaning, perform a post-inspection to ensure the area is completely free of asbestos residue and is safe for its intended use. Remember that the final cleanup process must be carried out by professionals trained in asbestos management and strictly follow applicable local and national regulations. Safety and proper documentation are essential at every stage of asbestos management. The final cleanup process includes thoroughly cleaning all surfaces that were exposed to the asbestos material. Yes, the final cleanup process after asbestos removal should include detailed cleaning of all surfaces that were exposed to the asbestos material. This thorough cleaning is essential to remove any asbestos residue that may be left on surfaces and ensure a safe, contaminant-free environment. Use wet cleaning methods, such as damp cloths or sponges, to pick up any dust or asbestos residue on surfaces. Wet cleaning is effective in preventing the dispersion of fibers into the air. Use vacuum cleaners equipped with high-efficiency filters, HEPA filters, to clean surfaces and remove fine asbestos particles. Make sure the vacuum cleaner is designed specifically for asbestos work and meets safety standards. Apply recommended decontamination solutions to ensure surfaces are completely cleaned and free of asbestos fibers. Follow the manufacturer's instructions and local regulations. Pay special attention to hidden or hard-to-reach areas where dust and asbestos fibers could accumulate. This includes nooks, crevices, air ducts, and other areas where particles may have settled. Collect and properly dispose of all cleaning materials, such as rags, sponges, and any other items used during the cleaning process. These items should be considered asbestos-contaminated materials and should be disposed of safely. Perform a detailed visual inspection to ensure that all surfaces are completely cleaned and free of asbestos residue. This inspection should be carried out with adequate lighting to detect possible particles. Conduct air quality testing and environmental monitoring after cleanup to verify asbestos fiber levels in the area are within acceptable limits. Document all detailed cleaning activities, including methods used, cleaning products, monitoring results, and any other relevant details. Detailed cleaning of all surfaces is essential to ensure safety and compliance after asbestos removal. Additionally, this process must be carried out by professionals trained in asbestos management to ensure that best practices and safety regulations are followed. During the final cleaning process, all tools used within the work area must be properly decontaminated and removed from the work area. Decontamination of tools is an essential part of safety protocol to prevent the spread of asbestos fibers and ensure that tools are not a source of contamination elsewhere. Here are some key steps to follow. Clean all tools used in the work area using appropriate decontamination methods. This may include the use of cleaning solutions, vacuum cleaners with HEPA filters, or other recommended procedures. Perform a visual inspection of each tool to ensure there is no visible asbestos residue. Pay attention to hard-to-reach areas, such as joints and crevices. Properly dispose of materials used during decontamination, such as rags and sponges, as asbestos-contaminated materials. Clearly label decontaminated tools as asbestos-free and store them safely. This helps avoid confusion and ensures that decontaminated tools are not mixed with those that still require decontamination. Remove all decontaminated tools from the work area safely. Avoid transporting contaminated tools outside the designated area to avoid contamination of other areas. Document the tool decontamination process, including the methods used and any issues identified during the inspection. Maintain detailed records for compliance and later review purposes. After removing tools from the work area, perform a final inspection to ensure that no contaminated tools have been overlooked. Proper tool decontamination is essential to maintain the safety and integrity of the work area and to prevent cross-contamination. This process must be carried out in accordance with local and national regulations, as well as industry best practices. The involvement of trained professionals in asbestos management is crucial to ensure that proper procedures are followed and all regulations are met. As part of the final cleaning process, we must remove 1 or 2 layers of plastic that we installed prior to removal to facilitate final cleaning. Removing previously installed layers of plastic is an essential part of the final cleanup process after asbestos removal. These layers of plastic, which are used to encapsulate and contain the work area during removal, are carefully removed as part of the cleaning and decontamination process. Before removing layers of plastic, perform a visual inspection of the area to ensure that all removal and cleaning operations have been completed satisfactorily. Ensure that all surfaces within the encapsulated area have been decontaminated and cleaned according to established procedures. Remove any waste material, asbestos residue, and objects within the encapsulated area. These must be handled in accordance with local and national regulations. Remove the layers of plastic one at a time, starting from the top and working your way down. Be sure to fold or roll the layers of plastic so that any potential debris is contained within them. If tools were used to install the plastic layers, decontaminate these tools before removing them from the area. Perform a final inspection of the area after removing the layers of plastic to ensure that there is no visible debris and that all areas are clean. Document the final cleaning process, including the removal of plastic layers, and detailed records. This documentation is crucial for regulatory compliance and future references. Dispose of layers of plastic appropriately, following local and national regulations for waste management. They may require disposal as asbestos-contaminated materials. Conducts air quality testing and environmental monitoring after removal of plastic layers to verify asbestos fiber levels are within acceptable limits. It is essential to follow all safety procedures and local regulations during each phase of the asbestos removal and cleanup process. The involvement of certified asbestos management professionals ensures that proper precautions are taken and all regulations are met. The critical barriers installed prior to the installation of the plastic on walls and floor must be left intact to avoid contamination to other areas. Critical barriers installed prior to plastic placement on walls and floors must be kept intact throughout the asbestos removal and cleanup process to prevent contamination of other areas. Critical barriers, which can include materials such as plastic sheeting, are an essential part of pollution control and are designed to prevent the spread of asbestos fibers beyond the designated work area. Here are some important guidelines to keep critical barriers intact. Regular inspection. Before, during, and after asbestos removal, perform regular inspections of critical barriers to ensure they have not been damaged or compromised during the process. Appropriate access closure. Ensure all entrances and exits to the work area are properly closed and sealed, using critical barriers as an additional line of defense against contamination. Avoid unnecessary activities. Minimize any activities that may affect critical barriers, such as sudden movements, unnecessary handling, or physical contact with barriers. Additional layers of protection. In some cases, additional layers of critical barriers can be installed to provide additional protection. This may include placing additional plastic sheeting or reinforcing existing barriers. Protection during final cleaning. During final cleaning, be careful not to compromise critical barriers while decontamination and waste removal are performed. Cautious plastic disposal. When removing layers of plastic used during removal, do so carefully to avoid damaging critical barriers. You can fold or roll the layers of plastic to contain potential debris. Continuous environmental control. Maintain continuous environmental monitoring throughout the process to ensure that critical barriers are functioning as expected and that no asbestos fibers are leaking. The integrity of critical barriers is essential to prevent cross-contamination and protect areas not involved in the asbestos removal process. Be sure to follow all safety supervisor recommendations and local regulations to ensure the effectiveness of critical barriers. Advantages and disadvantages of the asbestos removal process. The asbestos removal process is a specialized task that involves a series of specific precautions and steps to ensure worker safety and environmental protection. Here are some advantages and disadvantages associated with the asbestos removal process. Advantages. Health protection. Proper asbestos removal reduces the risk of exposure to asbestos fibers, which can cause serious respiratory diseases such as lung cancer and asbestosis. Regulatory compliance. Asbestos removal is carried out in compliance with specific regulations and standards intended to protect health and the environment. Structural safety improvement. Removing asbestos from structures or buildings can improve structural safety by removing deteriorated or damaged materials. Property value. Asbestos removal can increase the value of a property by eliminating health concerns and meeting current safety standards. Disadvantages. Economic cost. Asbestos removal can be expensive due to the need to comply with strict safety measures and specialized handling of contaminated materials. Possible fiber release. If not carried out correctly, the removal process can result in the release of asbestos fibers into the air, increasing the risk of exposure. Environmental impact. Asbestos removal can generate hazardous waste that must be managed and disposed of properly to avoid negative environmental impacts. Interruption of activities. Asbestos removal may require interruption of normal activities in buildings or structures, which may be inconvenient and impactful to occupants. Process complexity. Asbestos removal is a complex, technical process that requires the knowledge of certified professionals to ensure safety and regulatory compliance. Regulatory requirements. Regulatory requirements related to asbestos removal can be rigorous and must be strictly followed, which can increase the complexity of the process. It is essential to approach asbestos removal with extreme caution and comply with all applicable regulations. Hiring certified asbestos management professionals is essential to ensure a safe and effective process. In addition, specific circumstances and risk assessment should be considered before deciding to undertake asbestos removal. The next principle for asbestos removal is moisture. Water is the main tool to remove asbestos. The use of moisture, in the form of water, is an important principle in some asbestos removal methods. Applying water can help suppress asbestos fibers, minimizing their release into the air during the removal process. Here are some key points related to the use of moisture in asbestos removal. Dust suppression. The main objective of the application of water is to suppress the dust generated during asbestos removal. Water helps asbestos fibers adhere to surfaces and prevents them from dispersing into the air. Application methods. Water can be applied in a variety of ways, such as using sprinklers, sprayers, or even using systems that spray water directly onto work areas to maintain humidity. Humidity control. Maintaining a controlled level of humidity in the work area is crucial to ensuring effective dust suppression. Too much moisture can make it difficult for asbestos materials to stick and remove. Risk minimization. The application of water seeks to minimize the risks associated with asbestos removal, as wet fibers tend to adhere to surfaces and do not easily become aerosolized. Specific techniques. In some cases, specific techniques, such as water injection into materials with friable, easily crumbled asbestos, can be used to minimize fiber release. Environmental control. The application of water should be part of a broader environmental control that includes measures such as adequate ventilation and containment to ensure the safety and effectiveness of the process. It is important to note that although water application is a common technique in asbestos removal, its effectiveness depends on the type of asbestos-containing material, the specific site conditions, and the removal methodology employed. Additionally, excess moisture can have negative impacts, such as creating contaminated sludge, so it must be handled carefully. During removal, a water spray, also known as airless, should be used to keep the environment wet and asbestos fibers controlled. The use of an airless sprayer is a common and effective practice to keep the environment wet during asbestos removal. This approach is part of moisture control measures designed to suppress the release of asbestos fibers and reduce associated risks. Water spraying helps suppress dust generation, preventing asbestos fibers from becoming easily aerosolized and dispersed into the air. Water makes it easier for asbestos fibers to stick to surfaces, which helps prevent their release into the air and reduces the risk of exposure. The moisture provided by the water spray helps keep the asbestos material moist and controlled, making it easier to handle and reducing the risk of fiber shedding. By keeping the environment wet, the chance of asbestos fibers becoming airborne particles is reduced, helping to protect the health of workers. Continuous spraying of water during removal acts as a preventative measure to ensure that asbestos fibers remain in place and are not released during handling. It is part of a comprehensive environmental control approach that may also include adequate ventilation and other measures to ensure workplace safety. Importantly, water spraying must be carried out in a careful and controlled manner to avoid the creation of contaminated sludge and ensure the process is safe and effective. Additionally, the use of water sprinklers must be in line with local and national regulations, as well as industry best practices for asbestos removal. Advantages and disadvantages of using water in an asbestos removal project. There are significant advantages to using water in an asbestos removal project, but there are also important disadvantages and considerations to take into account. Here are some of the advantages and disadvantages associated with using water in asbestos removal projects. Advantages: dust suppression. Water is effective in suppressing dust generated during asbestos removal, minimizing the release of airborne fibers and reducing exposure risks. Risk reduction for workers. By keeping the area constantly moist, the likelihood of workers inhaling asbestos fibers is reduced, improving occupational safety and health. Fiber adhesion. Water helps asbestos fibers adhere to surfaces, preventing their dispersion and facilitating controlled handling. Environmental control. Contributes to the overall environmental control of the work area, providing an additional layer of safety throughout the removal process. Release risk minimization. Helps minimize the risks associated with the release of asbestos fibers into the environment and surrounding areas. Disadvantages. Generation of contaminated sludge. Excessive use of water can generate contaminated sludge, which can complicate waste management and proper disposal. Drain problems. In some cases, excess water can lead to drainage problems in the work area, affecting the effectiveness of the process and creating unsafe conditions. Possible impact on materials. In certain cases, water can affect specific materials, such as drywall, which can complicate removal and increase the complexity of the project. Precise control needed. Precise control of the water supply is required to avoid excesses that can generate sludge and ensure uniform application without waste. Greater operational complexity. Water management adds a layer of operational complexity to the project, requiring constant monitoring and adjustments to ensure its effectiveness. It is essential that the use of water in an asbestos removal project be carried out by trained professionals and in compliance with local and national regulations. In addition, constant environmental monitoring must be carried out to evaluate the effectiveness of the humidity control strategy implemented. Our last principle for asbestos removal would be to handle it with care. Careful handling is an essential principle in asbestos removal. This approach refers to the need to handle asbestos-containing materials and carry out all stages of the process with caution to minimize the release of fibers and protect the health of workers and the environment. Here are some key considerations associated with careful management of asbestos removal. Use of personal protective equipment, PPE. Workers should wear appropriate personal protective equipment, which may include protective suits, respirators, gloves, and other protective equipment to minimize direct exposure to asbestos fibers. Controlled material handling. Asbestos materials must be handled in a controlled and careful manner to avoid breakage, wear, or damage that could release fibers. This involves specific techniques for disassembling and removing materials without generating dust. Appropriate tools and methods. Specific tools and methods designed to minimize fiber release must be used. This may include wet cutting techniques, use of specialized tools, and approaches that reduce dust generation. Limitation of unnecessary activities. Avoiding unnecessary activities within the work area can reduce the risk of fiber release. Sudden movements and excessive handling should be avoided whenever possible. Constant supervision and control. Constant supervision by certified professionals is essential to ensure that all operations are carried out in accordance with applicable standards and regulations. Handle waste carefully. Disposal of asbestos-contaminated materials must be carried out following specific procedures to ensure safe and proper disposal. Protection of the surrounding environment. Additional barriers and measures should be implemented to protect the surrounding environment and prevent cross-contamination outside the designated work area. Staff training. All workers involved in asbestos removal must receive appropriate training in safe work practices and handling of asbestos materials. Continuous environmental control. Constant environmental control should be maintained to monitor fiber release and make adjustments as necessary throughout the removal process. Careful handling is essential to ensure that asbestos removal is carried out safely and effectively, minimizing risks to human health and the environment. Hiring certified professionals and strict adherence to local and national regulations are crucial in this process. Sometimes, we cannot cover walls or floors or use electrical appliances, such as in electrical or computer rooms or in hallways of buildings or hospitals. There are situations in which covering walls or floors, as well as the use of electrical appliances, may be more challenging or even prohibited due to specific environmental considerations. In such cases, it is critical to adjust asbestos removal practices to meet the specific requirements and restrictions of each location. Here are some strategies and considerations for addressing these particular situations. 1. Electrical or computer rooms. Insulation with polyethylene bags. Instead of covering walls and floors, polyethylene bags can be used to insulate the specific work area. These bags can be sealed tightly to contain the asbestos fibers. Safe disconnection of electricity. Prior to removal, a safe disconnection of electricity to the area must be performed. It is essential to work with electrical professionals to ensure safety during this process. Use of specific hand tools. If power tools cannot be used, specialized hand tools should be used that generate the least amount of dust possible and allow precise control. 2. Corridors of buildings or hospitals. Scheduling work after peak hours. Scheduling asbestos removal in hallways during times when there is less activity can reduce the impact on the normal operation of the building or hospital. Use of dust control techniques. Additional dust control techniques should be implemented, such as careful application of water or use of methods that minimize fiber dispersion. Implementation of temporary barriers. Using temporary barriers and mobile containment systems can be an effective way to isolate specific areas and reduce exposure of asbestos fibers to the surrounding environment. General considerations. Use of specific manual equipment and sensitive environments where power tools cannot be used. Manual tools should be used that generate less dust and allow more precise control. Specific ventilation systems. Implementing portable or specific ventilation systems for confined areas can help control the environment and reduce the concentration of asbestos fibers. Constant environmental monitoring. Maintain continuous environmental monitoring to evaluate the effectiveness of control measures and adjust them as necessary. In any situation, it is crucial to work with certified asbestos management professionals and comply with all applicable regulations and standards. Safety and exposure minimization are priorities in asbestos removal projects, especially in specific environments with particular limitations. Advantages and disadvantages of the careful handling process in asbestos removal. The careful handling process in asbestos removal has significant advantages in terms of health protection, minimization of fiber release, and overall workplace safety. However, it also involves particular challenges and considerations. Here are some advantages and disadvantages associated with careful handling in asbestos removal. Advantages. Workers' health protection. Careful handling reduces workers' exposure to asbestos fibers, protecting their health and preventing risks associated with respiratory diseases. Fiber release minimization. The release of asbestos fibers is reduced by following procedures and techniques that minimize the generation of dust during removal. Protection of the surrounding environment. The careful approach helps protect the surrounding environment by reducing the potential for cross-contamination and the spread of asbestos fibers outside the work area. Regulatory compliance. Careful handling is essential to comply with local and national regulations and standards related to asbestos removal. Workplace safety. Contributes to creating a safe work environment by implementing practices and measures that minimize the risks associated with handling asbestos materials. Continuous environmental control. Constant environmental control can be maintained, monitoring fiber release and making adjustments as necessary throughout the removal process. Disadvantages. Operational complexity. Careful management can add operational complexity to the project as it involves the implementation of specific procedures and additional control measures. Greater time and cost. Implementing careful management practices may require more time and resources, which may increase the costs associated with the asbestos removal project. Area coverage restrictions. In some cases, there may be restrictions on wall or floor coverage, which may complicate the process and require alternative approaches. Limitations on the use of tools. In sensitive environments, there may be limitations on the use of power tools, which could affect the efficiency of the removal process. Need for specialized personnel. Careful handling requires the involvement of specialized and certified asbestos removal personnel, which could increase labor costs. Risk of damage to materials. Careful handling involves techniques that prevent damage to materials, but there may be cases where careful handling is more difficult, especially in fragile materials. It is essential to balance the advantages and disadvantages of careful handling to ensure that safe and effective practices are implemented during asbestos removal. Hiring certified professionals and strict compliance with regulations are crucial in this process. It is always good maintenance practice to try to keep asbestos materials in good condition to prolong their use and performance. The practice of keeping asbestos-containing materials in good condition whenever possible is an important strategy in the safe management of asbestos. Here are some reasons why it is a good practice. 1. Prevention of fiber release. Keeping asbestos-containing materials in good condition helps prevent wear and tear and the release of asbestos fibers into the environment. Exposure to asbestos fibers is a significant health risk. 2. Minimization of risks in the workplace. By keeping asbestos-containing materials in good condition, you reduce the risk of exposure to workers during maintenance or repair activities. This contributes to a safer work environment. 3. Extension of useful use. Keeping asbestos-containing materials in good condition can prolong their useful life, which can be beneficial in situations where immediate removal is not practical or cost-effective. 4. Continuous evaluation and monitoring. The practice of maintaining asbestos-containing materials in good condition allows for continuous evaluation and monitoring of their condition. This makes it easier to identify problems early and implement preventive measures. 5. Regulatory compliance. Keeping asbestos-containing materials in good condition is consistent with occupational safety regulations and standards, which often require responsible management of asbestos-containing materials. 6. Long-term cost reduction. It may be more cost-effective to keep asbestos-containing materials in good condition than to perform costly and potentially complicated removals. This is especially relevant in situations where removal is not immediately necessary. 7. Staff training and awareness. Promoting the practice of maintaining asbestos materials in good condition involves training and raising awareness of staff on the importance of safe asbestos management. 'There are 4 types of asbestos removal classes. In general, asbestos removal can be classified into different categories or classes depending on the magnitude and complexity of the work. These classes are designed to guide and standardize asbestos removal procedures, ensuring safe practices and regulatory compliance. Here are the 4 typical types of asbestos removal. Class 1. Removal of materials with friable asbestos. Description: it involves the removal of asbestos-containing materials that are friable, that is, they can be reduced to powder with hand pressure. Work examples: asbestos pipe insulation, easily crumbly bulk material. Class 2. Removal of materials with non-friable asbestos. Description: involves the removal of asbestos-containing materials that are not easily reducible to dust. Work examples: asbestos-backed vinyl tiles, non-friable materials such as asbestos cement. Class 3. Removal of small quantities of asbestos material for maintenance. Description: refers to the removal of small quantities of asbestos-containing materials during maintenance work. Work examples: minor repairs involving the removal of asbestos materials, maintenance work in which small amounts of asbestos are found. Class 4. Janitorial asbestos care. Description: involves operations and maintenance of asbestos-containing materials that do not involve their removal. Work examples: regular inspections and evaluations of asbestos materials, maintenance activities that do not require asbestos removal. It is crucial to follow local and national regulations and work with certified asbestos removal professionals, regardless of the specific classification used. Safety and health protection should be top priorities in any asbestos removal project. No matter how small or how large the asbestos removal work area is, there should always be at least 2 people inside during removal or maintenance work. For security questions, The presence of at least 2 people during asbestos removal or maintenance work is standard practice and an essential safety measure. This is due to several reasons. Emergencies and mutual assistance. In the event of an emergency, such as accidental inhalation of asbestos fibers or any other incident, the presence of at least 2 people allows for mutual assistance and rapid response. Continuous monitoring. Having 2 people present makes it easier to continually monitor working conditions and the environment. They can collaborate to ensure that safety procedures are followed and to detect any unsafe situations in a timely manner. Support in case of injury or fatigue. In situations where significant physical effort is required, such as lifting heavy equipment or materials, having another person present provides support and helps prevent fatigue-related injuries. Reciprocal observation. Reciprocal observation between 2 people can help identify potential hazards or unsafe conditions that might be overlooked if one person is working alone. Compliance with security protocols. In many locations, the presence of at least 2 people during asbestos removal work is a regulatory and workplace safety requirement. Effective communication. Effective communication is essential in any work task. Having 2 people present facilitates constant communication about the progress of the work and any changes in conditions. Rescue protocols. In the case of work in confined spaces, where there may be additional risks, the presence of a colleague is crucial to carry out rescue protocols if necessary. It is important to note that these safety measures apply regardless of the size of the work area. Whether it is a small repair or a more extensive removal, the presence of at least 2 people contributes significantly to the overall safety of the process. Additionally, it is essential that all workers are properly trained and certified in asbestos removal and that established safety procedures are followed. Activities and procedures prohibited within the work area. Prohibiting the consumption of food, smoking, using cosmetics, or chewing tobacco within the work area where asbestos removal is carried out is a critical safety measure. Here is why these activities are prohibited. Personal pollution prevention. Eating food, smoking, using cosmetics, or chewing tobacco can result in ingestion, inhalation, or absorption of asbestos particles. These activities can contaminate food, utensils, tobacco products, and cosmetic products, which could pose health risks. Respiratory protection. Smoking and chewing tobacco increase the risk of inhaling asbestos fibers. Additionally, the use of cosmetic products could introduce asbestos particles into the skin or areas near the respiratory tract. Cross-contamination. Accidental ingestion of asbestos particles can occur if food is consumed in a contaminated area. Likewise, smoking or using cosmetic products in a contaminated environment can lead to cross-contamination of other areas or surfaces. Passive inhalation risk. Asbestos particles can remain in the air for some time after removal. Smoking in these areas increases the risk of passive inhalation of the fibers by those not directly involved in the work. Regulatory compliance. Prohibiting these activities is commonly a regulatory and occupational safety requirement to comply with local and national regulations related to asbestos management. Focus on safety. Maintaining a work area free of activities that may increase the risk of asbestos exposure reflects an ongoing commitment to the safety and health protection of workers and others present in the area. It is essential that all persons involved in asbestos-related activities understand and strictly follow these prohibitions, as well as any other established safety protocols. Awareness and compliance are essential to minimize the risks associated with asbestos exposure. In conclusion, an asbestos removal program is a critical undertaking that requires careful planning and execution to ensure worker safety and environmental protection. Throughout this course, we have explored the fundamental principles of asbestos removal, highlighting the importance of certification, thorough evaluation of the work area, and implementation of controlled removal techniques. We have examined the various asbestos management methods, from encapsulation to removal, and understood the advantages and disadvantages associated with each approach. Additionally, we have highlighted the need for certified professionals to carry out asbestos removal and the importance of continually evaluating environmental conditions during the process. We have explored work area preparation, including covering floors and walls with polyethylene, installing critical barriers, and creating decontamination areas. We have also discussed the importance of implementing safety measures, such as continuous environmental monitoring and post-removal decontamination. Emphasis was placed on the need to follow strict prohibitions within the work area, such as consuming food, smoking, using cosmetics, or chewing tobacco, with the aim of preventing contamination and protecting the health of workers. At the completion stage of an asbestos removal program, the importance of inspection, environmental monitoring, and safe waste disposal was stressed. Detailed documentation, final report, and administrative closure are also crucial elements to ensure regulatory compliance and establish long-term follow-up. In short, asbestos removal is a delicate task that requires attention to detail, rigorous adherence to safety protocols, and ongoing commitment to best environmental practices. By incorporating these principles into the planning and execution of asbestos removal programs, we can significantly contribute to worker safety and the preservation of the environment. Remember, you can contact Active Environmental Training at any time if you feel you have questions or concerns related to this or any other professional safety or environmental issue. Call Active Environmental Training at 407-860-0369 or visit us on the internet at www.activet.com. Your comments are always welcome. Thank you.